short explainer video on geometric sums. I hope you enjoy. So, uh, what is a geometric sum, you might ask? Uh, well, first you need to know what a geometric series is, and a geometric sum is basically the sum of every single number in a geometric sequence. So, what is a geometric sequence, you might ask? Well, it's a sequence where you have a starting number such as a, okay, and with each next number in the sequence, you're multiplying by the common ratio r. For example, you'd go from ar to ar squared to ar cubed. You get the point, right? Okay. So a geometric sum will just be the sum of all of these. So we'll usually call geometric sum S, and we'll say that's a plus ar squared, just summing up all the members in the sequence, all the way up to ar to the n. Okay. We want to calculate what is S in terms of ar and n. Well, I'll show you how to do that right now. First, we can just say, since this is S, then we can say that S times R is equal to AR plus AR squared all the way up to AR to the N plus AR to the N plus 1. Since what we're doing is we're multiplying each number by N. Or not there. But, yep, okay. So now what we can do is we can subtract S of R from S to get S of R minus 1 equals, all these guys cancel out. Everything in the middle cancels out with everything in the middle here. So what we get is just AR to the N plus 1 subtract A. And then this is what we have. We divide both sides by R minus 1 to get S equals AR to the N plus 1 minus A divided by R minus 1. I'll rewrite this at the top, and what I'll do is I'll factor out the a. So how you can see that there's an a in the numerator here, I'll just factor that out to get that s equals a times r to the n plus 1 minus 1 over r minus 1. This is our formula, okay? So you might think, what happens when n is infinite? You might ask. For example, for some sums, n will go to infinity, and you might think, what happens then? I'll show you right now, okay? So, let's say r is greater than 0, then when n goes to infinity, then this r to the n plus 1 goes to infinity. So what happens, r is greater than 1? Then what happens is this goes to infinity, so our whole thing goes to infinity. If r is less than 1, then when our n goes to infinity, then what's going to happen is this will go to 0, because like 1/2 to the bajillionth power just gets really, really close to 0. I mean, since this is going to infinity, it will go to 0. Of course, this only works up to -1. I won't be talking about what happens when you take negative numbers below -1, but you can kind of see what happens, right? I don't think it's very hard. Yeah, because if you take, for example, -1/2 to the bajillionth power, then what happens is this will just approach 0, right? It'll fluctuate. Like, let's say you take -1/2. What's gonna happen is this is 0, this is -1/2. It'll go to a quarter, then a -8. It'll get closer and closer without ever hitting 0. That's what actually happens. So we can say that this goes to 0. Of course, for a number like -2, that won't happen. It will just fluctuate, like, So this is what we say. And then what we say is that if r is less than -1, then it's undefined. Okay? Yeah. So instead of just writing it as r is greater than -1 and less than 1, what we actually say is that modulus of r is less than 1. But what modulus does is it measures the distance from 0. So like -2, the distance from 0 is 2. 3, the distance from 0 is 3. This definition might sound stupid, but it makes more sense in the complex plane. Actually, I won't be talking about the complex plane, actually. It's not a good idea. Yeah. Okay. So as we know, modulus of r has to be less than 1. If it's not less than 1, then it's either infinity or undefined. right? So yeah, it can have some pretty cool uses. A well-known example is the bouncing ball question. Um, won't be talking about that here since it's a short video, but you can Google it. It's a physics problem, and it uses this concept of geometric sums. I recommend trying it. If you'd like to do so, try doing these geometric sums. So a equals 3, r equals 1/2. Try doing a equals 6 and r equals a third, and then try doing a equals -1 and r equals 2. Okay, you learn the most from practice, and if you already forgot, then the formula is s equals a times r to the n plus 1 minus 1 over r minus 1. I hope you enjoyed this video. I'll probably be doing another short explainer video today. Bye bye.